By the end of this video, students should be able to calculate the molar mass, percent composition, and molar mass conversions. To do this, you should have the completed practice quiz, which is found on Edline. For questions 1 through 4, you should have the following molar masses. We will do number 1 and number 2 as practice or demonstration problems. The first step is to determine what the formula is for calcium bromide. In this case, you're going to look up on the periodic table and find out the charges of the two ions. Since they are not going to add up to 0, you'll end up needing to have 2 bromines to make the compound add up to 0, therefore CaBr2. This molecule has 1 calcium atom and 2 bromines. You will look up their masses off the periodic table. Calcium has a molar mass of 40.08. So the 1 calcium atom times by 40.08 equals 40.08. Bromine has a mass of 79.90. Remember, we're rounding everything off to 2 numbers past the decimal place for molar mass. So 2 bromines times by 79.90, the mass for each one, is 159.80 grams. Add it together and you get a grand total of 199.88 grams per mole. Do not forget to put down the units on your answer. This number will be used on future problems. Iron 2 hydroxide. In this case, when the Roman numeral is given to you, that is the charge on the atom. So this is an iron plus 2. Hydroxide is a polyatomic ion. You will look that up and see that it is a -1. Similar to the last problem, we want the molecules to always have a grand total of 0 or neutral charge. To make this happen, I will need to have 2 hydroxides. So I have FeOH with the parentheses because it's a polyatomic ion and a 2 subscript. For the molar mass, I have 1 Fe. I have 2 times 1. I have 2 oxygens. And I have 2 times 1. I have 2 hydrogens. I am going to look up their molar masses off the periodic table and round each one to 2 numbers past the decimal place. So oxygen will become 16.00. Hydrogen will be 1.01. Now I need to know the grand total of each element in the compound. There's only 1 Fe, so it is 55.85. But there's 2 oxygens, so 2 times 16 is 32. There is 2 hydrogens, so it's 2.02. Add all this together, I get 89.87 grams per mole. Don't forget the units on the final answer. This number, similar to the rest that you have in the molar mass section, will be used on future problems. Let's try number 5. To determine the percent composition of oxygen and iron 2 hydroxide. First off, my formula is the percent composition is equal to the total mass of the element over the molar mass times by 100. So I'm going to go back to my number 2 problem and find out what was the total mass of oxygen and what was the molar mass of iron 2 hydroxide. And this is the work that I did on a previous problem. So from here we can see that my mass of oxygen was 32 and my mass of the whole compound put together, my molar mass, was 89.87. Let's write that in so we don't forget it. 32.00 and 89.87. I'm now going to push this out of my way so I don't have to worry about it anymore. Okay, and as on all kinds of percents, it's part over whole. So my percent composition will be the total mass of the element in question, oxygen, which is 32, over the molar mass, 89.87, times by 100, which gives me a total of 35.61. 4 sig figs, 4 sig figs. This isn't exact. This is my overall answer. Now you might say, well, why the 32? Why not 16? And once again, we want to get the total mass of the element in the compound. Since there's 2 oxygens, it's not just 16, it's 32. That's the total of all the oxygen put together. Okay, let's go down to some of the conversion problems. We want to convert 4.20 moles of calcium bromide to grams. First thing, we want to know what that molar mass was from the previous step. So up above in our problem, we found that calcium bromide had a molar mass of 199.88 grams per mole. Now we're going to start with a given. 4.20 moles. And we have our setup. The purpose of factor label method is to use the units to show you what to do. So whatever our unit is up here, the unit comes down. We have moles here, moles comes down. The rest of the unit we want to find out will go on the top. Now we're going to come over here and take a look at our conversion factor. It is 199.88 grams per 1 mole. So the 199.88 grams goes together. And since we've already determined that the grams goes on top, that means the 199.88 goes on the top and 1 mole goes on the bottom. So I'm going to multiply across the top 4.20 times by the mass divided by 1 equals my final answer, which in this case is 839 grams. 3 significant figures because this has 3 sig figs and this one has 5, but 3 is less. Let's try the one down below. To begin with, to go between grams and moles, we need the molar mass. We have the molar mass from a previous column up at the top of the page. This was 213.01 grams per mole. We're now going to start with our given, 238 grams. Okay, factor label method is always about using the units to show you what to do. Our unit here has to come down so it can cancel out. The rest of the unit goes on top. So the grams comes down just like the moles had come down beforehand. Now let's go up and take a look at our conversion factor and see which number goes where. We have 213.01 grams per mole. Which means the 213.01 grams goes together. Since grams is on the bottom, the 213.01 goes on the bottom, and the 1 mole goes on the top. So we're going to do 238 times by 1 divided by 213.01. because in math class, you multiply across the top, you divide your bottoms. When you're done, you get 1.12 moles. 3 significant figures because this has 3, this has 5, but 3 is less. Let's look at the difference between the two problems. While we always start with a given, then we always use the conversion factor. The difference is what unit goes where. Whatever the unit is on top has to go on the bottom so they can cancel out and leave you with the desired unit. Whatever unit is on top has to go on the bottom so they can cancel out and leave you with the desired unit. Let's try another problem of the same type. Looking at the top, our molar mass, which we had already calculated in the section 1 through 4, was 42.39 grams per mole. We're going to start with a given. Then we're going to use the conversion factor of molar mass. Whatever this unit is has to come down, and the rest of it goes on the top. That way moles can cancel. Taking a look at our problem, our molar mass conversion problem. We have 42.39 grams. They go together per 1 mole. This means when we come over to our problem, we want to put the 42.39 grams together. And we've established here that the grams goes on top. So the 42.39 also goes on the top. And the 1 mole goes on the bottom. Multiply going across, we get 0.30 grams is our final answer. 2 significant figures because this has 2 and that one has 4.